Near-Earth objects are really just that. These are celestial objects that come near to the Earth. And there are broadly two classes, near-Earth asteroids and comets. The near-Earth asteroids, they mostly come from the asteroid main belt, which is between Mars and Jupiter. And it can happen that because of a collision or because of an interaction with one of the planets, one of them falls down from its orbit in the main belt to an orbit that brings it closer to the Sun and therefore closer to the Earth. The near-Earth objects, there are a few big ones, there are many more small ones, and there are many, many more very small ones. We know most of the big ones. Big is 1 kilometer or more. For those that are 100 meters, we know about 10%. For those that are 10 meters, we know less than 1% of them. And so that's annoying because an object that is 10 meters in diameter on impact with the Earth would release about the same energy as a Hiroshima bomb. We are trying to characterize everything that is bigger than 20 or 50 or 100 meters, where we are at 10% now, so we still need to find 90%. In terms of numbers, we know 10, 20,000 of them, and we are still missing 90%. So there is a lot of work to find them and to track them. To discover near-Earth objects, you need a super wide-angle telescope. And then you just scan the whole sky, night after night, in order to see everything that is moving. The asteroids are moving, and so we have a computer program that will find them, measure their position, and from this position we can extrapolate the orbit, and we refine the orbit until we have an orbit that is good enough that we will not lose the asteroid again. We know from history and also looking at the moon that there are many impacts. On average, a small one, which is like a few tens of meters, that happens every few years. Bigger ones are fortunately less frequent because there are fewer of these objects. Very big ones are even less frequent because there are very, very few of them. So if you take a very big one, like 15 or 20 kilometer asteroids hitting the Earth. Last one was 65 million years ago. That was bad for the dinosaurs. And historically, we see this kind of giant impact every 50 million years or so. To predict an impact with a near-Earth asteroid, a near-Earth object, you need to know its orbit very precisely. And so to do that, you need to measure the position of the object on the sky over and over and over. It's difficult because many of these objects are small and they are not always near the Earth. They can be on the other side of the solar system. And the combination of their size and their distance makes them extremely faint, which means that most of the time the telescope that discovered them, which is 2-meter class telescope, can observe them only for a few days, and then they cannot see them anymore because they become too faint. And that's where the VLT, the 8-meter big telescope, come into play, because with the collecting power of the huge mirror, we can see much fainter asteroids. Using the VLT, we refine the orbit of the near-Earth objects, the threatening ones, those that could have a collision, in order to make sure that the orbit is known well enough, either to rule out a collision, that's ideal, or to characterize a collision. To protect ourselves from a near-Earth object, we must know them and prepare in advance before a collision. So if we have enough time, 20 years or so, we can send a rocket and do something to the asteroid. That can be nuke it, atomic bomb, either to try to destroy it or to push it. Or there are some more gentle ways. Cute way to do it is to spray paint the asteroid with bright white paint, because that will change the way it reflects the sunlight, and that can be sufficient to push it away from its orbit. Or you could also land a small rocket on the asteroid and let this small rocket push it. Or if it's a very small asteroid, you can go cast a net, grab it and pull it away.